Hello everyone, I welcome you to the second part in the pre-calculus section regarding the laws of exponents topic. So today we're going to continue with some new examples, and the reason for that is I want to make sure that we all comprehend the techniques and approaches necessary to solve each problem and to modify each scenario. Okay? Alright, so let's begin. We have our first exercise, and that will be, let's see, we got 5x to the minus 2 over 6y to the minus 2 as well, and all of that is being raised to the negative 3 power. Okay, so how can we go about this? Well, a smart choice will be to simply split them up, and I mean both portions of the function. Okay, so we could rewrite this as 5x to the minus 2 and all of that raised to the negative 3rd power. And same with this part, 6y to the minus 2 also raised to the 3rd power. So now, in the following step you must be careful, because now we have these coefficients here, but we can simply use this formula here for them, but you have to remember that these negative exponents here, that is only affecting either the x and the y, okay, not the coefficients, and this is what I mean. So we can simply express all of that as 1 over 5 to the 3rd power, applying this formula here. In this case, a is 5, n is simply negative 3, so that is how we transition that portion of the problem. Okay, and then times, well, we got x to the minus 2, and then we have an outside exponent of negative 3. You can simply multiply them. So what is negative 2 times negative 3? Obviously that is x to the 6. Okay, and we do the same with the bottom part of the equation. So it will be 1 over 6 to the 3rd power. You see? Then times y times y times y to the 6th power, same as the one in the top, right? So to further simplify this, we have x to the 6th power. What is 5 to the 3rd power? That is simply 125, right? Over y to the 6th power. 6 to the 3rd power, that will be 216, if I'm not mistaken. So now we got these two portions dividing each other. And you may ask yourself, well, how can we simplify this even further? And that is not hard at all. If you recall from previous video, I say you could simply multiply times the reciprocal. When you're dividing two functions, simply multiply by the reciprocal of the one on the bottom, which is this one here. So all of this is equal to x to the 6 over 125 times 216. That is the reciprocal of this one here. Okay, so don't get complicated. Over y to the 6th power. So now multiplying, we simply get 216 x to the 6th power over 125 y to the 6th power. And that's it. That is your answer. Now, what is the key in each of these problems? Well, the best thing that you could do is simply knowing how to apply these formulas. That is the key. Each one of them plays a small portion in every exercise. Okay, that is really important. Alright, so let's move on to the next exercise. So this one is more of a simplification or simply reducing the terms. So let's see what we got here. We got a 2 to the 3x to the 4th power yc, and all of that to the 2nd power over 3 to the 2nd power xy to the 3rd power and c. Now notice how in this one there's no parentheses in this one here. So parentheses, it makes a difference, so you have to be careful with that. Okay, so let's evaluate this one. Well, negative 2 to the 3rd power, that is simply negative 8, right? Then we got x to the 4th power. You know what, let me move this a little bit down. Okay, so let's work here. So this will be negative 8 x to the 4th power, then multiply yz to the 2nd power. Okay, let's see. So what is 3 to the 2nd power? Well, that's 9. And this remains the same. Y 3rd power and z. Right? So yeah, this one we can leave it like this. There's no further simplification that I see here. Okay, y to the 3rd, z, yeah, looks fine to me. So let's continue with another one. Let me clean all this. Okay, so for C, we have x to the minus 2 y over xy to the 2nd power. So, if you recall from previous video, when we have a certain variable or coefficient to a negative exponent, we can use this formula here. So in this case, our a is simply x, and our n will be negative 2. You see the difference? Okay. So having said that, we can go about it in the following way. 1 over x to the second power, because that is the transformation that you see there, times y over x times y to the second power. Right? Fair enough. Now, 1 over x squared times y, that is simply y over x squared divided by x y squared. Okay. So, how can you go about these two fractions? Well, that is one fraction. This is simply another term. So, well, you can simply multiply again times the reciprocal. So I have y over x to the second power times, remember this is the same as x times y squared over 1. Right, so multiplying times the reciprocal, that is equivalent to 1 over x y squared. And of course this is the same as, let me split this here so you don't confuse yourself. This is the same as y over, well, you can simply multiply the x's. So x squared times x, that is simply x to the cube. And then the other term is y squared. Okay, so this is your final solution. So these are not that complicated. This is pretty straightforward. Again, it's simply about using these formulas here. Okay, so let's keep moving to the other examples. Let's see what else I got. So now we have 4x to the negative 2 times yz parentheses, oh, no, to the negative 1, okay, divided by 2 to the third power x to the fourth and y. Okay, so once again, using the same formulas, we can rewrite this as 4 times x being affected by negative 2. We use this one again. So that will be the same as 1 over x to the second power times, once again, the same formula, 1 over y times z, because this is negative 1. So all of that divided by 2 to the third power x 4 y. Okay, let me check. Yeah, everything seems good. So now let me simplify this a little bit. 4 over x squared y z. Okay, all of that divided by, what is 2 to the third power? That is 8. X to the fourth times y. Remember, this has 1 in the bottom, as to make it more simple. Okay, so now you have 4 over x to the second power yz We'll reduce this a little so we have more space. Okay, times. What is the reciprocal of this? Well, that is simply 1 over a. Be careful here, you don't mix them. Ax to the 4th power times y. Okay, so now this is equal to 4 over x squared yz a x to the 4th y. So what can you see here? What do you see? You can simplify this 4 and this 8 divided by 4. So what do you get? Well, you get 1 over x squared yz. Remember, we divided 8 by 4 though, so that's 2x to the 4th power times y. And this is your final answer. Okay? So now to conclude, I will include these last exercises. So we have, these are fairly simple, okay? I'm just gonna try to use the other formulas with these exercises. So we have x to the negative 3 times x to the 5th power. And now, take a look at this formula here. You have the same base, so which here in the formula is referred as an a. That means you can simply add the exponents, right? So what is this equal to? Well, x to the negative 3 plus 5. And of course that is simply equal to x squared. Simple as that. Right. So let's do another one. Now we have x to the minus 3 to the 2nd power. Now we got these two terms here. Just like we did in the previous examples, you can multiply them. See that there? Exactly. So this is the same as x to the negative 6th power. And by using now this formula again, we realize that that is the same as 1 over x to the 6th power. Okay? So now let's do the last example. We have 2 over 3 to the 4th power. Now this is the same as expressing this portion is the same as rewriting it in this way: 2 to the 4th over 3 to the 4th power as well, because both the numbers are being affected by this 4. Take a look at this formula here. You see that? That is exactly what is going on here. So this would be 16, I believe. Yes, over 81, if I'm not mistaken. And that is it. This concludes our basic examples. This is more of a review, okay? Just so you have an idea of how the laws of exponents work.